our online students. Okay. Okay, so what we will do is we will go over the derivation at sonic speeds, and then we will discuss how to proceed. So what is the problem statement? The problem statement is pretty straightforward, right? So I need not this one, just this one. So this is the problem statement. See, if I hold it like this, you see all the pages. So you technically have shear between the layers of the pages, right? That's why you see this kind of a dip. Now, if I just clamp it from here, in fact, if I had a clamp, I could have shown you, and then I would have hung it, you would see that this thing will not even deflect like this. So you can see that there is definitely a shearing between these pages. The whole point is that when you have a beam on which you are putting load, there is definitely a shear like this, right? But the point is, even between the layers in the longitudinal direction, you have this shearing, right? So essentially what we want to do is we really want to have an expression for the longitudinal shear. Because when I want to talk about this shear, what was my philosophy? Somebody is putting a load like this. Let me make sure that our students can see me. Oh, students cannot see me. Let me pin. Okay. So essentially, if I'm putting a load here and I used to ask you, can you give me the average shear stress? What you used to do was you used to make a cut, throw the chunk away, find the V, and used to tell me shear stress is equal to, average shear stress is equal to V over A, right? So essentially on this surface, you used to give me an average shear stress. I am telling you that there is a longitudinal shear that exists between the layers. We want to find that. Okay, problem statement clear? Okay, so derivation again, I will go through sonic speeds, but I will explain everything. Screen. This is your problem statement. I have a beam, I have loads on it. Somebody told me that shear stress is equal to V over A, and I was feeling happy. They told me that bending stress is equal to My over I. I already knew it. What I am doing is I make a section, I take a chunk out of it, and I'm now focusing on it, calling it as small a. Now, this is what you have to understand. Now you are saying why we keep on talking about these hypothetical scenarios. Oh, you want to talk about this shear. Let me tell you something. If I want to make let's say a beam that is made up of two different materials like this one, you see, so I have a plank of wood and I have another plank and I have pinned them together, right? Now, technically, I can use it to take loads. Just imagine if I am putting a load from the top, I have this bad feeling that the place by which they are connected together using the pin, it cannot sustain that probably, because there would be shearing between them. Pretty much what you indicated when we were talking about bending stresses, you said, I feel that at this particular junction, there should be maximum stresses, right? And I told you what you are referring to is something shear. So this is why we are talking about this longitudinal shear. Are you getting my point? Okay, so now that you are convinced, this is a little chunk that I took. For students who are saying, why this chunk? What I'm saying is, do you see this little layer? Let's say I have glued this with this big chunk, or I have pinned it with this chunk. So technically this glue can, or this pins can cut. Okay, now when I'm putting a load from the top, I know that this whole thing will bend and I will have what is known as bending stresses, right? So right now I am taking an element from here. I zoom it in. Come on. I zoom it in, and when there is no hybrid teaching next semester, I'm telling you. So when I put load from the top and it goes like this, then I know that there will be bending stresses that will be varying like this. There is a neutral axis that is somewhere here, I don't know. That's why bending stresses keep on decreasing all the way up to the neutral axis. There are students who are saying, what is this delta H? That horizontal, that longitudinal shear, right? What about this surface? It will have a vertical shear for sure, because you're putting load from the top. What will be here? Another shear. What will be on the top? The distributed load that you are subjecting this object to. Do I have a shear here? No, because I have taken the chunk from the top surface. The top surface does not have any shear. This sentence was very important. I said the top surface does not have any shear. Okay. This is a free surface. Does it have any shear? No, it doesn't have any shear. Remember this. These are the conceptual mistakes that everyone tends to make. So remember, I took this whole object and I said summation of forces in the x direction equal to 0. Delta H is the force that exists here. That's fine. On the left and right, I have two different forces which are bending. So I said delta H plus integral of bending forces over the whole dA equal to 0. I substituted instead of stress my over I. I substituted and I got a quick expression that goes along like delta H is equal to delta M over IQ. And finally, I said delta H is equal to VQ over I delta X. And eventually I wrote two different expressions, these two. I have to explain these two expressions, then I will again revise this and I will focus on individual elements. What is this delta H? Well, that's the shear that exists. Please focus here. That exists here on this layer. That exists on this layer. This layer, this layer, this layer, this layer, this layer, this whole layer, or this layer, this layer, this layer. This longitudinal shear is my delta H because I want to pin two planks of wood together, and I'm afraid that when I put the load, it will not be able to sustain that load because of shearing. Delta H force I got. So delta H, the shearing force, is equal to VQ over I delta X. Now you tell me, what is V? What is V? Of course, that's a force, but you have to tell me which force.
From upwards, the force.
The load that you are applying, what do you call it? The transverse? I think transverse is the right English. Well, like this is a beam. That's the load that you're applying. What is the V? You know how to find the V. You make a cut, you throw the chunk away, you find the V. The transverse here. So that's the V that you all find, right? Okay, that's the V. You multiply with some Q. I will explain what is Q. You divide by the moment of inertia of the cross section. Good. And then you multiply with delta X. I have to explain the Q. So this Q is, if you see, I wrote here somewhere, I don't know. Q is equal to integral y dA. Yeah, Q is equal to y bar A, first moment of area above the plane. So I know it's confusing, but you have to just hang in there with me. You see, these two planks of wood, I connected them with pins or glued them together. So the Q is of this little chunk. Q is for this little chunk. How do we find it? I will explain to you later. If you glue this big chunk with little chunk here, you glue them together, then this little box right at the end, you will have to find its Q. So Q is the first moment of area of the section above the plane of the plane above the section of interest. So for example, you have to find the first moment of area for this little chunk if you want to find the Q. Okay, then what about delta X? I know it's confusing, just hang in there with me. We will solve examples today. What is delta X? I don't know, you just figure out what is delta X, delta X, delta X, delta X. Okay, now everyone is saying, okay, we understand that the X direction is longitudinal. What do you mean by delta X? So you see, you have two of these that you have use pins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pins. Delta x is the distance between the pins. I have 5 meter long, 2 planks. I connected them together. How many pins I need for that structure to sustain the shear? So this delta x will give me that distance. You can even see it from here. Delta x.
We don't have pins. What if it's been glued or clamped? Or
If you have glued them together,
well,
then you will find the shear flow. So I understand your question. This is what you will do. You will take this delta x on the left hand side. So you will get the shear force per unit meter, and then you can calculate the average. Then you can calculate the shear stress using the area. That will give you an estimate what is the shear stress, and then subsequently you can decide glue, material, whatever. So I will answer your question focusing here. What if we don't have pins? Well, I will divide the delta H with T delta X to find the average shear stress. Now there are students who are getting confused with so many terms. What is delta X? Let's go back. That is how many pins distance you want along the way. What is T? I mark the T in this direction. Here you can put a question mark in your notes. At one point, I might tell you that T is probably in this direction as well. We will decide, okay, once we come across such kind of a question. But as of now, our T is like this. Okay, for those of you who want me to quickly repeat the two formulas, should I or should I continue? Should I revise the problem statement for those of you who came 2 minutes late? Problem statement is clear. Anyone?
I didn't understand the DA part, the cross section.
DA?
Yeah,
this is the DA.
No, the lower one, DA.
This DA.
This,
Yeah, so this DA I took out from here, I zoomed it in. I'm talking about the fact that load is being applied from the top and there are shear between the layers. They can go like, the shear force on the left face here is V on the C face on the top, V on the D face is, let's say, on the bottom, towards bottom, I'm sorry. Delta H is towards right, let's say, because if this is clockwise, it gives me towards right. The top surface does not have any shear because this is the top surface. Top surface does not have shear, of course. Surface does not, the top or bottom surface, extreme bottom does not have shear. The distributed load is acting from the top, W delta X. Then I took this whole chunk. If you are wondering about the yellow arrows, these are the bending stresses. Because at the end of the day, when you're putting load from the top, the whole thing wants to bend. So I went here and did the summation of forces equal to 0. Should I continue? Is anyone feeling lost? Or should I just directly make an example?
Can you repeat what Q was again, please?
Q is very confusing. The 90% problem is figuring out Q. Q is the first moment of area above the plane for the section of interest. So for example, if you have glued these two together, then this little chunk, you have to find its Q. Above this plane, the place where it is glued together. So moment of area, first moment of area above the plane. Q is equal to Y bar A. Okay. Okay, and for those of you who want me to just tell you two formulas instead of this long story, I think he's writing, so I will wait for our students. When you are done, you just let me know, There are 2-3 students who are writing. So understand the problem statement. You should not come 1 minute late. This is the problem statement. It's when you hang, the layers tend to slide. So there is shearing between them. You clamp them together. You see? So shearing, that's why they are behaving like this. This is the problem statement. We're talking about the longitudinal shear. Okay, anyways, on that note, I have to proceed. Come on, come on, come on, come on, come on. Life is beautiful. Just hang in there with me, please. Okay, so this is my today's problem. My problem says that I have a very nice and beautiful okay, why don't you all quickly, please make this on your notepads. So let me copy this picture and then we will do this together, hoping to crack it. Okay, I will just start to remove these things from last semester. Oh, come on. What on earth did I make this for? Anyways, I have to remove this. I have to remove this. Okay.
The dimensions of the beam are accurate?
They are accurate. I doubt that there will be a mistake, although there is a little possibility. Okay, what is the question? The question is shear force in each nail. In each nail. Okay. Now, number one thing that you have to do is write the two formulas that I went over. But for the two formulas, delta H is equal to Q Q delta X, and Q delta X was VQ over I delta X. Okay. So the small q is known as the shear flow. You have to say it from your mouth. You can just murmur shear flow. Small q is shear flow. Okay. Small q is shear flow because if you enter into graduate studies, they will keep on using this shear flow, I think. VQ over I delta X is your formula. The second formula that I went over in this class is shear stress. No, sorry, it was V. Hang on with me, please. Oh, come on. Where is that formula? God. VQ over IT, I suppose. VQ over IT. And I used to write average here as well, which is equal to tau xy. Now, there are a lot of students who are saying, like, come on. You said average shear stress is equal to V over A. Load is being applied. What is shear stress? You throw that chunk away. V over A. Why are you teaching us this? I told you longitudinal shear, because at the end of the day, between each layer there is longitudinal shear. I want to talk about this layer. I'm fed up with talking about the whole cross section in an average shear in this direction. So for that, I need average shear in that longitudinal layer. Yes. Okay.
Shear average is the nails shear average or? Yeah, we say
this is longitudinal. This is longitudinal. This is between the layers. Between each particular layer.
In physics, but we do not consider the thickness of the shear, but we are telling that the shear force in the nail. So obviously, thicker nail would have experienced lesser stress. Am I wrong?
Hang on. I need to answer your question.
Or is it because they are in the same layer? Do they all experience the same stress regardless of?
I think you ended up answering the question as well, because if it's one layer, because we will see that in the bending stresses, the bending stress was minimum on the neutral axis, used to be 0, maximum away from the neutral axis. Here, the maximum shear stress would be on the neutral axis, and at each particular layer, it will have a particular value. I do realize your question. I think one answer might be the one that you already answered, but why don't you give me probably a few minutes? If we finish this question, probably I can think about it. That what about the dia? That is a good question, and I will think about it. What about the dia? Why aren't we talking about it? Probably one answer can be the one you already said. Oh yeah, the answer is probably at the end. Okay, I got it. The answer has your answer. Okay, we will do it together first. So all of you, why don't you help me in this problem then? The first thing I want from you is give me the y bar a of a. What is my a? In your textbook, they use the a prime, but I will use the small a. I suppose this is my a. Why? Because when somebody is using the pins, they are using the pins to connect this plank of wood with this plank of wood. So of course the pin goes right through it, right? So this is the layer of contact. So why don't you all focus on this layer, please, and then highlight the area away from the neutral axis. So I highlight the area with yellow, and I set Q is equal to y bar a. It is equal to something multiplied by something. What is this something? I suppose it is 100 multiplied by 20. I'm sure students will agree with me. And this y bar, well, I will let you use the imagination. Wow, that was quick. How did you figure? Very good.
The distance between the neutral axis and the centroid.
Very nice. That was a good answer. These y bar things will need time. So from the neutral axis, very nice, to the centroid of the section of interest. Good answer. Very nice. 50. I think this is how we figured out. Okay. So this cube will, trust me, can confuse you. What is this cube? But that's y bar a. Okay. I don't know, 60 into 100 into 20. Okay. And it will give me 6 2s are 12. 9, 120 000 millimeter power 3. Okay. Okay. By the way, our online students are not contributing or asking any question. Ehsan, Togukan, Revis, Tashinchan, Aisha, if you have any comments, please feel free to stop me. What about the moment of inertia? Moment of inertia is for the whole cross section. Never, ever did I tell you that it is for any little chunk. For the whole thing. So for the whole cross section, it is equal to, okay, do it. This is, use your imagination, give me the moment of inertia. I think you have enough background to crack the moment of inertia for the whole cross section.
So we are going to take the moment of inertia of the only the rectangle at the top.
For the whole moment of inertia, we are crystal clear. For the whole thing. For the whole thing. So if you have to find the moment of inertia for the whole thing, of course you have to use bit of trick and maths. So you will find the moment of inertia of this rectangle about neutral axis. Then you will find the moment of inertia of this rectangle about neutral axis. 100% of the times we have found the moment of inertia in this class, I think, about neutral axis, right? In bending stresses, we find about neutral axis. And even here, then you find the moment of inertia about the neutral axis. Just remember that for this top one, you have to use parallel axis theorem. And for the bottom one, you have to use the parallel axis theorem. For the center one, there is no parallel axis theorem. You will be able to crack it directly. Is there any student who is feeling confused and or do it? What about BH cube over 12, gentlemen, BH cube over 12.
Also, we each know the formulas for aerogen.
Huh? Just talking about BH cube over 12.
Just
BH cube over 12.
so
We'll use AD squared as well.
What is it? For the AD square, of course. AD square you already know. BH cube over 12 plus AD square for the top one and bottom one. Give it a try, give it a try. Give it a try. You did?
Hocam you said BH
Over 12. BH cube over 12.
that wasn't BH.
Cube over 12. I'm making you do it because these are the places where we all tend to make mistakes.
And plus AD square.
Plus AD square, the Penrose-Lexus theorem. Anyone who gets the answer, tell me. You don't hesitate, even if the answer you think is wrong. Every shear stress. This is a formula. We are not finding it.
We don't have to know it's T and.
No, we just need moment of inertia. Find it. BH cube by 12. Okay, I will help you. Look, you have to say BH cube over 12. Okay. BH cube over 12. Okay. For the web plus for the flange. How many flange I have? Anyone? 2. So 2 flange I have, and I will put like this. So I will say BH cube for them. So instead of doing like this, let me do it directly. It will be 1 over 12 into 20, correct? How many students are agreeing right now? Multiply by H, 100 power 3 plus 1 over 12 multiply by, 1 minute, I hope everyone can listen. Hassan Revis, can you hear me? 12 into,
Yes, sir.
okay, 1 over 12 into, anyone?
It is 16.2 millimeters square.
You got it? Answer? Ha, good, very good. Very nice. Acha. Okay.
YB is 20.
Huh?
YB is 20. Isn't 20 sir?
20. Yeah, this one. B H cube over 12. Okay. Plus 1 over 12 into 100. Why don't you double check? 20 power 3. Okay. But I have to use parallel axis theorem plus 100 into 20 A into D square. What is D? Again, good answer from our students. I'm impressed. 60 square. So we have I equal to 16.2 into 10 power minus 6 millimeter power 4. Did you get the same answer? Positive. Oh, thank you. Yes. So let me convert it into meters. Sorry. I wrote in the.
Hocam, there is a double flange.
There is a web. Then this is the flange, and then this is also a nice and beautiful flange. Okay. No? Yes?
We didn't calculate inertia lower frequency.
We did. Two. Did I multiply with the 2?
No.
Okay, thank you. My mistake, sorry. I multiply with the 2. Okay, then finish the question for me, everyone. Now, so I have delta H nail is equal to V is given to me as 500 Newton multiplied by Q is given to me as, sorry, I calculated as 120,000.
And that's, 10 power 6, not 10 power minus 6.
No, I converted into meter power 4. I converted into meter power 4. Okay. Yes. 120,000 divided by I is, please bear with me, 16.2 into 10 power minus 6, and 120,000 divided by 10 power 3 multiply by 3, I think, no? Right? Why? Sorry, 10 power 3, yeah, multiply by 3, I think. Okay, so this is VQ, and finally I have delta X, which is,
0.0.
did they give us? 25 millimeter, 25 by 1000. Why don't you use a calculator and give me the answer? Is this clear why I did a 10 power 3 into 3? No?
Yeah, you converted millimeter to the power to
Ah.
meter.
I converted millimeter power 3 into meter power 3. Okay.
You did that by taking the power of to the minus 3 millimeter.
But I put it in the denominator. I converted in simple terms millimeter power 3 of Q to meter power 3. This one to meter power 3.
Could you explain Q again, John? I didn't understand. Q of A is equals Y bar times.
Yeah, first moment of area of the section of interest above the plane. So Q will be for this little yellow chunk because it is connected to the rest of the object here. So I have to find the first moment of area for this object. First moment of area is AY bar. What did you get?
92.6.
It seems reasonable. Oh, sorry. Did I answer your question? Y bar A, Q. It is the first moment of area above the plane of interest for the section of interest above this plane, away from the neutral axis. I don't want to use the word above. I want to use the word away from the neutral axis. Just imagine, just to confuse you, if I had asked you the same question for this chunk. Can everyone focus? This is important. If I had asked you to give me the answers for this one and pins had been from the bottom, you would have done, I think, pretty much the same thing. So it will be away from the neutral axis. So don't use the word finding Q above the section of interest. You can say finding Q away from the neutral axis. Not sure whether I was able to convey it properly.
And also Y bar and D are the same thing, right?
Huh?
Y bar and D are the same thing.
D?
In AD squared, right? We said D.
Nahin, nahin.
AD squared.
Nahin.
For the D, it will be Y bar, right? In this particular region.
Acha. Oh, ho, ho.
Is that
Yes. Good. Thank you. Yes.
Y bar and D will be equal.
It will be equal in this particular case. I don't want to. Huh?
Are they equal?
Here in this, I don't know. I have to think about it. But in this particular case, you are right. I don't want to use the word in general. Why would I say in general?
Because we always talking about the distance from the neutral axis.
No. I will not use the word in general because just imagine if I change this section here, this big chunk, then the D will change. So I will not say it is equal.
And also Y bar is changed.
No, but for the top section of interest, the Y bar is the same, no? From here all the way. Oh, no, 1 minute. Sorry, but then the neutral axis will also change. So I cannot answer the. Yeah, I cannot say yes or no. I'm so sorry. I don't know. In general, I cannot say such a statement. Okay, so it will be 93 Newton. So probably we are also coming to,
Can I ask something?
yes, yes, please.
Why didn't we use, to find the y bar equation that we only use for, beams?
Which
No,
y
no,
bar?
where we have the sum of, yi times a y divided by the sum of a.
Yeah, because that equation for finding y bar is for finding the centroid of the structure. Here in this particular question, if I ask you, what is the centroid of this whole structure? No.
Because it's, what you call it, I guess reflected in the y-axis.
Ah.
That's why we can just find y bar just looking at it.
Very good. So the neutral axis, you answered the question. The neutral axis is right through the center. So why would I find the centroid for this one? Okay, so this also I am trying to answer his question, 93 Newton per nail. So if it is 93 Newton per nail of, then we can also find the diameter of the pin of each nail, because now I know that this is the 93 Newton that one pin has to sustain. So I know that shear stress is equal to V by A. If I know the material from which I am building that pin and diameter of that pin, then shear stress is equal to 93 divided by the area of that pin.
So this is the force, not the stress.
Delta H.
Then we are-
Oh yeah, delta H is the force.
Okay. Okay,
So-
okay, I get it.
You get it? Okay, good. Okay, I hope I was able to convey.
So T is the thickness, right? In this question, yeah.
This one?
T is the thickness, right?
This one, right?
Uh-huh.
Yeah, so it is.
Thickness of the nail.
No. Thickness is this one. I'm happy that you pointed this out. I will explain. Hang in there with me, everyone. This is confusing, by the way, because this is difficult than bending. This is T. This is T. Shear stress is equal to VQ over IT. This is the T. And I will do one more problem and we will cover this T. But what I'm saying is remain open to this T, because probably in another question, I may say that this is the T. We will see. But as of now, this is the thickness T that I'm considering. Okay. And we haven't used that T till now. Okay. Please bear with me.
Thickness of the layer.
Thickness of the layer. Thickness of the layer of contact. We will, yes. So that is joined with this one. That's your T. Okay, I will answer your questions by making another problem. Please bear with me. So why don't you, okay, please don't look at the answers and let me just copy this for you. We will do it together. How did I?
For the previous question,
Yes.
what was the answer for?
93 Newton per nail. Delta H is equal to 93.
Are we trying to find the shear force, right?
Yes, we tried to find the shear force that each nail is subjected to. So, okay, gentlemen, ladies and gentlemen, why don't you all please do this question for me? Huh?
So what's the difference between V and H?
Huh? What?
Hocam, in the beginning we say, in all course, we say V is shear force.
Huh?
Now we say A delta H is shear force.
Oh, good question. V is, I put load over it. This thing can, this transverse shear, if you want to call, this is the V. But at the end of the day, when I'm putting a load like this, there are shear forces between these layers. That's why I keep using his register to show you. This is H. Okay, now why don't you solve this question? By the way, before you start a question, Can anyone answer? How did someone give me Vmax is equal to 500 Newton in this question? How did they give me this 500 Newton? Anyone?
It's given in the question.
Yeah, but how? Well, like, for example, if I give you a practical problem, would you be able to figure out the Vmax? In an exam, in a very general question, would you be able to find Vmax? If I don't give you, if what is given? Okay, so for example, if I give you a beam, then this is what you will do. I say that this is the distributed load. I don't know, some value. Think about it yourself. Let's say 500 Newton per meter. And then I have another load of 250 Newton on a span of, let's say, 5 meter. This is my A. I'm giving you an example, okay? Can you find the Vmax? Of course you can. From statics rules, you throw the chunk away, find the shear force diagram. You have gone through statics, everyone, right? Find the shear force diagram, calculate the maximum shear Vmax, then you start the problem. Okay, so just remember that this is how somebody has given me Vmax. Okay, I'm coming to your desks. Do it. Things are getting clear or they are becoming confusing?
Two questions.
No, it's the same question. This is one question. Oh, you mean this is part one, part two.
The normal axis is given or
Given.
Neutral axis is given to make your life easy. In an exam setting, if I really want to make your life difficult, I will say find the neutral axis. How would you find the neutral axis? You will find the centroid. How would you find the centroid? You will make a reference line and then you will start that, I don't know, horrendous procedure of
Wait, so
math.
this axis is given, so you don't have to find it.
In this particular case, I have provided 68.3.
Oh, okay.
I have
I was going to begin. Find it.
Yeah, I see. Okay, for those of you who are wondering what is the V? V is 15. V is 15 in this problem. If you go to our canteen, what is that cafe? Which cafe? Which is right beside the dorms on the way to in front of Lemar. Even if you see their tables, their wooden tables, they have these pins. They have connected them using pins. So of course, if someone has to make 2 or 3 of these tables, oh come on, who would want to go through this process? Or even going through some FEM software. But if they have to make, the company has to make 5,000 of them, they don't want to mess up. So definitely an engineer has gone through the calculation. You see this one? Hang on. You see this one? So this curved portion and this curved portion, you don't know how to calculate the bending stresses till now. This is curve. I haven't taught you the curve. But you see this straight, this is also going through bending, right? Bending, MYO. Yeah.
When we say shear stress, this is confusing why shear force and shear stress is related. But when you're talking about layers, shear stress,
This is average pressure.
not average.
Okay, then now that you're talking about this average stress,
I couldn't understand the layers in shear stress.
Because-
Like the H when you say the H is the this one, yeah, this one.
When you hold it, or a thick register like this, when I hold it from the layers tend to skid. So every, this layer and this layer, each layer has shearing. Just imagine that these are wooden fibers. And I'm putting load over them. Each wooden fibers layers, they all tend to skid. So this shearing is between their layers. So when you are putting a load like this, you are subjecting the object to this mass of shear, that's fine. But there is a longitudinal shear in each layer. And each layer has a particular longitudinal shear, and we are trying to find each layer.
For example, yeah, when the force is like this.
No,
The
the force is being applied in the shear is like this, but subsequently there is a shear force that in this it will be added to this layer and this. And each layer has a different force.
So, what is the area for the whole part, right? So whole part is the area.
No, okay, you will have that question answered in this particular question, which is the area. As of now, what I just want from you is just give me the clue. Give me the clue, and I will answer the question. What is the area? Here I will show you the area. Okay. What did you say?
Sir, when we are calculating Q, which of the surface should we take? The top one or the bottom?
Are you talking about A or B?
For part A,
Matlab A.
Q. When we are calculating Q.
A. For A or B, that's what I'm saying. For A. So for A, you use the top one.
I think it's the area of the yellow color.
Okay.
Yeah. So I will answer both your questions. Give me the I first. Then give me the QA, and I will answer Abdullah's question. QA is equal to Y bar A. Okay. What is Y bar? It is the top one, right? So I don't know. You give me 100 into 20. So Y bar is
This is for A or B.
A. First I will do A, then I will do B. 40.
41.7.
Oh, you figured it out. How did you do it? 68.3. This is 20. This is 40. No, sorry. How are you doing it? 120 minus.
Minus 10.
Okay, I think everyone is saying the same thing. Okay, good. Then 100. Okay, give me the value. 83.4. I calculated. Thank you. 10 power minus 6 meter power. Give me the I. What is I? Okay, you will do it yourself. 8.63 into 10 power minus 6 meter power 4. What? Now I will answer your question. Mehmet, right? Your question was, which area are we talking about? Oh, your question was area. Oh, I am about to answer, I think something a little different, but probably that will answer your question indirectly. What is the V? 15? Oh, come on. That's not 15. I'm so sorry. 15 kilonewton. Oh, come on. It's not possible. Just does not make any sense. 15 Newton, like that's a kilonewton. Someone is going through all this pain to subject it to 15 Newton. That's pretty funny, right? Okay, everyone. Then I get answer of, give me answer please, kilonewton is 15,000 into Q, 83.4 into 10 power minus 6 meter power 3 divided by, oh, come on, I is 8.63. Moment of inertia of the complete section. Okay, I will again repeat. Q will be of the section of interest away from the neutral axis, away from the Q will be for the above the or away from the plane of interest, whereas I will be for the complete thing. Okay, multiply by T. What is T?
Thickness of the layer, which is the contact layer.
Very nice. Contact layer is the right answer. Nice word. I wanted everyone to focus on contact. 20 millimeter. Oh, what is this 20 meter? Is it millimeter? Yeah, I think I made a mistake. Thickness is 20 millimeter, as one of the students has told us. Give me the value of average shear stress. Boom. So look, I do realize when you say area, so you think like this. You see this layer thickness of contact. If you take it to the third dimension, so that will be the area that we are talking about for those fibers.
So the contact area will be the
This
area.
one, this green little chunk.
It will be the area for the
Area of interest,
shear.
huh? But of course, I've glued it, I've pinned these two together over that area.
And also, there is a force acting here and
Huh?
also force acting here, which is delta H.
Yeah, there is a delta H that is acting.
So it's similar to V divided by area, because delta H will be V, the V will be delta H, the area will be the contact.
Delta H will not be V. Delta H will not be V. You can say synonymous if you want to use the word. They are different. They are different now. Values. What is the average? No? Anyone? Can anyone give me the value? 7.25 megapascals. Can you please at least double check for me? Thank you. I appreciate it. QB, definitely do it. Now, the same thing you will do for QB, but away from it. So for QB, you will have the bottom chunk. Don't use the word above. For B, it will be below, right? So it will be, I will just finish the question. I think our class has understood. So QB is equal to Y bar into the Y bar for the 2 multiplied by the area of the chunk 2, which will be 60 over 1000 multiplied by 20 by 1000. That is the area multiplied by 58.3, correct? Divided by 1000. Okay, which is equal to 70 into 10 power minus 6 meter power 3, and my average shear stress becomes, what happened? Abdullah has a question. Okay, 70 multiplied by 10 power minus 6 divided by 8.63 into 10 power minus 6. Give me the thickness. What is the thickness? Is the same, right? Yeah. I think for the top and bottom, the same. Multiply by 0.02. The answer comes out to be 6.0. Yes, good. Thank you. You see, so kilopascals. Are you sure?
Kilopascal. Okay.
I think.
Is a mega.
Okay.
For finding the I,
Moment of inertia for the whole thing.
the whole thing. Did we do for the middle part, which is
For the whole thing.
connecting?
For the whole thing. I keep on saying for moment of inertia is for
In the web part, did we add a B square? Did we do that?
here.
Yes.
Of course, we would have.
Because centroid is not
Yes,
in
the answer to your question is yes. Of course, we would have if we had done it. Okay. Okay, everyone. Should we continue or do you need a break? Sorry, I closed it. Sorry. It is 608 kilopascals. Okay. Should we do one more problem? Okay. Really? A, B, C, 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 1 downwards. Okay, we can have a 5-minute break, and in the meanwhile, I will create another problem for you. Please, I request you to be back at 11:40 now. Anyways. Okay, so let's do this together. Don't look at the answers, please. We will do it together, figure out. So that's nice. Copy. Huh? What happened? Okay. Copy selected graphic. What happened? Oh, come on. Hang in there with me, please. Yeah. Okay, now we can start. Okay. Okay, so why don't all of you now? Okay, what is the problem? The problem is, come on. Okay. So find the every shear stress in at point A and at point B. That's the question. When you come back, we will do. So sir, I'm having for Monday. What if you come after the classes? I think I will take a couple of days on Saturday. Again, I'm busy. So right after the class, why don't you have a look at
I asked my friend for him to look at my grades, but he wasn't sure, so
Okay.
I'm just curious, you know.
Okay.
I think I know like
an estimate?
the estimate, but I'm not really sure. So I just wanted to ask. No worries. Yeah.
That's fine.
Burada 608 yok. 608 kaldı. 06 evet. Biri 7 yaptı, hiç çıktı. 06 çıktı.
I would like to ask you something, please. In the pendulum system, when we want to, let's say, write the equations of motion, we divide the mass
Yes.
into the vertical and the tangential directions, and let's
Radial and
look
polar.
at the radial direction.
And
The force, net
Uh-huh.
force is this, mg sinus theta times the distance.
Oh,
because
you are doing the summation of moment?
Mhm.
Okay, do it.
Times distance is
Okay.
equal to
Uh,
the I times
Theta double dot.
the
Do it. I theta double dot. Yeah, you're correct actually. Good.
and the I is actually the L times M, right?
Yeah, there is just one mistake, and it's not even, I don't know, it becomes confusing. Actually, there is a minus sign here. you will realize you have to put a minus sign here. Below, before mg. Before mg. So let me, I can explain it like this because this becomes a little confusing so many times. If you have, this is the bob, right, and this is your theta, right, in the positive sense, and then you divide this into its components. This is my mg, this is as you drew, and this is your theta. Then this is the mg sine theta, as you said. Then you do summation of moment about the point of rotation equal to I alpha, which is equal to I theta double dot. We will talk about I later. Then this one, you can see you will have a clockwise, let's say, because this definitely is opposite to your positive sense of theta, minus mg sine of theta into, as you said, the moment arm, which is the L. So, which is equal to, what is I? Now, I haven't covered in class, but here in this particular case, it is M R square. So, ML square. You can double check ML square. So, it is M L square theta double dot. Now, you take them on the same side of the equation and we will see whether we have made a mistake or not. Plus ML square theta double dot equal to 0. M square L theta double dot plus G over L sin theta equal to 0. For unforced pendulum, this is the equation of motion. You were pretty close, but for the mass moment of inertia, it is ML square. But if, for example, this rigid rod was not massless, this rigid rod, let's say in a hypothetical scenario, this is rigid. Of course, it is rigid, even in this case, for sure. That's why you are getting this. But let's say it had itself another mass. Then definitely this problem will become a little more complicated because now you have to incorporate the fact because then you have two different masses now. So the equation of motion will be a little different.
Because in the greatest homework 8, last question was actually about the equations of motion of pendulum in the dynamic course.
In our grade homework?
Yeah. And I saw it, but the thing is,
I have
where did I get? But in the great homework, it also gave the answer.
Okay.
So where did I get? Was always the half of the answer that it gives.
Did you figure out the problem now?
Well,
You have to.
I didn't take the ML square. I just took it as L.
I for this particular case is MR square, but finding I also needs practice, and I don't think we have even covered this part. But you can show me the question and we can figure it out together.
I don't know how to look at it. Yeah.
Okay, Abdullah, that's the question then. Why don't you find the shear stress at section A and B? But this is definitely a little different, if not difficult, than the bending one, right? Bending one was more like MY over I. Okay, well, apparently.
When we say delta H, what is delta H nail? If you can repeat.
Force. The force that nail is being subjected to. Delta H that you found, that was the Newton per nail. So let's go back if you want. Delta H nail, 93 Newton per nail. So delta H that you calculated is 93 Newton per nail per delta X.
So we can say that 500 Newton was being applied, but 93 Newton is subjected to per nail. Is this right?
Good. So for example, hang on. The 500 Newton, for example, is the maximum shear. I was subjecting it to load transverse shears by finding the statics shear diagram. I saw Vmax is this. Good. Then somebody was like, let's say I am putting nails after every 25 millimeter. Can you just tell me how much force each nail is being subjected to? And you can flip the question as well. The flip part will be if these are the pins, somebody shows you the pins, this is the diameter of that pin, this is the material of the pin, and you say this is the maximum shear stress that each pin can sustain. Subsequently, that's the maximum force each can sustain. Give me the distance with which you will have to put those nails to connect them together for the whole thing to sustain a maximum shear force of 500 Newton in the transverse direction. You get my point? But break is not ending, everyone. Come, we start 40 to 45. Okay. Okay. Okay, Ghazal, Bahadur, Mirch, and we have Abu. Can you please start this? Give me the shear stress at A and B quickly. Give me the shear stress at A and B. Oh, where are the values? So the question says that V is, let's say, I don't know the V actually. I have to find it. Can you please give me then 2 minutes? Because right now I'm not sure about the V. I don't know about the V. That's not good. Okay, then probably I will give you just some hypothetical value. Why did I write 100,000 here? Anyways, I will just give you a V for this problem myself. Let's say V is, I don't know, 10, 5 kilonewton. Not that much. Will you be able to give me the answers, huh? Okay, do it. But how will you do it? What about the neutral axis? Given. Okay, thank God. You are trying to give me the average shear stress at the point A and at point B. So you can think it like that. For example, somebody had that little piece, the green one, and they glued it. So that's your A. Or somebody had that big chunk right from the bottom all the way up to B, and they glued it. So you have to give me the shear stress, let's say, at A, at B.
So John, A is little part
Huh?
and B is old.
A is what?
A is little part, B is old.
Huh.
Not on the A and
No, I think I have to zoom in. Okay. This is A. This is B. Okay.
The question asks for the average shear stress.
At A and B, yeah, I think I have to write it. I'm not writing it. So let me write it down for you. Give me the T average at A, T average at B. And just so that I just want to be sure that everyone is understanding everything. Um, you can also give me the maximum shear stress on the neutral axis. Okay. So add another part to it. Give me the T average at NA as well. Okay. If you are considering the B, let's say if you are considering A, then A will be the green chunk. That's the area. Find the Q for it. If you are considering the B, that's the big rectangle. Find the Q for that one. Write the formula.
And I will use
For what? For I? Oh, I did not give you I. I don't know, just find it. Parallel axis, yeah, for sure. Oh. Okay, I will give you the I. Oh, come on. I want you to focus on something else. Otherwise, you will spend all your energy in finding I. So I is 33.725. This is your home task. Use the parallel axis theorem and everything and do it yourself. I'm not gonna do it for you. And so ironic that there are no units to it. Millimeter power 4 seems reasonable, I think.
What is V?
Huh?
What is V?
V? 5. I just came up with the value because my notes are not talking about it.
5 Newton.
Kilo. Okay, now I think I have waited for all of you. I'm going for it. So T average A, I have to find the QA, which is equal to AY bar, which is equal to 38 multiplied by 20 multiplied by Y bar, which will be 19 plus, oh God, that is hard. 19 plus,
114.6 minus 9.
right. I don't know. I have to think about it. Is he right? Yeah, he's right, I think. Good. Good answer. 114.6 minus 19.
Yeah.
Okay, you have to double check, please. I don't think it's in my notes now. Okay. Then I have to divide it with 1,000. Right? Oh no. I cannot, right? Because 1,000. Oh yeah, I think I can. Or I can't, sorry.
Then there's also another 1,000 in the bottom of it.
What? And now it's correct now? Okay. So which is equal to, nice answer. I think he's right. I appreciate it. And QB equal to, no, but okay, you can ask me if anything confuses you. 38 multiplied by, not 38. Now it will be 76, right? This part is clear or not?
Yes,
Sure. Is there any student of a class who forgot to take the whole area? Anyone? Everyone knows that, no? Good. Okay. So we have 76 multiplied by 20 multiplied by
114.6 minus
38
minus 38 minus 19.
Okay, this is difficult. So let me think about it. You said minus 38
38 plus 19.
minus 19, right?
Could you remind me why did we take the Entire area.
Yeah, because the rule says, okay, let us go back to the rule. The rule says that if you are taking the B, right? So you have to go away from the, so I keep on saying above at the beginning of the class. That's why I was stopping. Above, I mean away from the neutral axis. So if this is the glued area, this is my B, and this is A. So forget the A for now, okay? A I can think about later. So away, this is my neutral axis. Away from the neutral axis, so it will be whole thing.
minus 9.
No?
Understand.
Sure. Okay, good.
Ajam, will we do minus 19 or not?
Did I do? I did it, no?
Yeah, that's good.
I did it minus 19.
Doesn't be the entire thing.
Yeah. Oh, I did a. Sorry, I made a mistake.
We will just ignore A, isn't it?
Sorry. What happened? You said, would we ignore the A?
Yeah, when we are talking about B.
Why would I ignore B?
Transfer this would be.
नहीं, एक मिनट.
Be the entire chunk, which consists of the part A.
So
Why we are taking the centroid of A?
oh, sorry. I think I made a mistake. Yeah, thank you. Good remark. Sorry. If I'm taking the whole rectangle, it will be this minus 38. Thank you. It will be 76. Okay, thank you. I made a mistake.
So B is basically, B has A in it as well, right?
Yeah.
Here.
Of course. Thank you. Otherwise, I would have ended up making a mistake. Yes, please.
And also, A and B are the parts, the thin lines, right? Not the. How can I express myself? The A is the point at the 38 millimeter above the bottom side surface, right?
Okay.
Is that true, Hocam?
38.
Also B, the point at or line at 76 millimeters.
So that's why 76 divided by 2.
bottom side surface.
That's why 76 divided by 2 I did. That's why he said, why are you considering the A1? Why are you doing that? That was a mistake. So I did a 76 divided by 2 here, 38.
So, for example, if we
Yeah, please.
if we talk about the upper part, for
Yeah.
example,
And neutral axis.
not neutral, it's like B and 12 millimeters above the B,
Yeah.
for example.
Okay.
So
So we will
we
take
need
that. We will
take the whole area
away from the
above
neutral axis. Away from
it, right?
away from the neutral axis.
Okay.
Okay, so we will have QB equal to
116,
116.
10 power minus 6 meter cube.
0.43 into 10 power minus.
6 meter cube.
Thank you. I appreciate it. And since you gave me this answer in that form, I have to change it to meter. Thank you. So it was divided by 1000 power 3 meter power 3. Okay. Okay. Then, we already. Oh, okay. So, give me the answer in. No, we did not actually, because the answer I am writing is in millis. So divided by. I did not have the calculator actually. 38. Oh. Okay, give me the value again, everyone.
7.27 times 10 to the power minus 5.
7 point, yeah, that's what I'm saying. Thank you for reminding again. 7.26 into 10 power.
Minus 5.
Yeah, that seems correct. 7.265 10 power. Okay. Okay, now give me the value of equal to, and then I have equal to whatever. Give me the value in Newton per meter square.
I found 539.
Okay, you have to compare your answers with each other. I don't have the answers. Everyone?
Our answers are same.
539 kilopascals.
539
Yes.
kilopascals, then
And then 863 kilopascals.
take it. Okay.
Yes, sir.
Okay, everyone. By the way, for neutral axis, I am also thinking which area will you, which cube will you consider, the top one or bottom one? Anyways, think about it. That's why I'm not adding the part C. So we can skip it for now. Something for you to think about.
What was the part?
That's why I'm not talking about it now. Part C was find the maximum. I'm sorry. Find the average shear stress at neutral axis. So I'm skipping it for now. Think about it yourself. Okay, now open this one. Do these two problems for yourself quickly. Don't see the solution, see the question, then see whether you can do it or not. For our online students, I have to open the textbook. And then I will give you a homework task. Okay. Strength of materials. So we have one of them has a page number. Can you please give me the page number from the book? Ye wala. If you can please.
438.
438. Okay, our students who are watching online, can you please open your textbooks yourself, or please go over this one? So you have to be careful. Look, this one is different, right? How is it different? Anyone who can figure out why is this problem different than what I have been telling you till now? Right? So it goes like from good. So it's different, right? So nail is not like this, it is like this. So our students have answered. The nail is now like this. So again, solve it. Do it. No. No. So for example, this beam is going in the third dimension. Somebody has put the load on the top. Probably in this, they haven't mentioned it, but I'm telling you, I know as a fact, the load is from the top, unless somebody gives you some other situation. The load is from the top. But what you have to understand is that the person who was making this, that person had a plank of wood, and that's how he connected them. The load is from the top, but pin has the ability to shear from here. That doesn't mean that load is from a different. If the load is from the top, how would this beam bend like this? Where would be the neutral axis? Like this. In the exam, I created something different. I put the load in two different directions, and that's why your neutral axis changed from here to there.
Why don't you have thickness?
Because it doesn't ask for the stress in the mail, it just asks for the force.
It is not asking us to give us the average shear stress in that layer. In that layer, the other two layers are connected. But if I ask you the average shear stress, the formula will be VQ over IT. And that's why I told you even previously that T I might change. So probably what will be the thickness in this question? If you use VQ over IT, then I think the thickness will be.
But it says determine the shearing force in each nail.
That's what I'm saying. You're not getting my point. What I'm saying is, what if they had asked us to find the average shear stress in that whole layer? If somebody had put a glue, so VQ over IT, then your T would be that little chunk at which they are connected. That's why I told you in the beginning of the class, the T is not necessarily like this. Probably T can be like this as well, because that's the place they are connected. Did everyone understand why is this AY bar? Huh? Everyone? Everyone?
Can I ask something, please?
Mhm.
So in this situation, why is the neutral axis vertical? I don't understand.
I never said that neutral axis is vertical. Who said that?
At first, that's what I understood.
I never said that. He asked me the question, where would be the neutral axis? I said the force is being applied from the top. The neutral axis is still the way it is. I never said that.
It doesn't change. Why does it change here? Why does the question answer like this?
I'm not following your question. Let me come to this.
The answer is when they are solving, when they answer, you can clearly see there is the neutral axis is vertical.
No, it's not.
Look, what is the dashed line?
This is the neutral axis. It's a line of symmetry. Load is applied from the top.
I got confused with the two lines.
Okay, hang on. The question is different than the other questions because the pin is like this. So this section and this are connected from here. Previously, this plank and another plank used to be connected from a pin that was going like this.
So what does that change?
It changes this. Now your area is this little chunk.
So if they were connected like before, we will consider areas like the part on the left, like.
I will explain it. Hang on. Like this.
So here, the yellow parts and the purple dashed lines are connected by nail like this.
That's why you used the whole thing like this. So I will answer your question like this. Oh, come on, what happened to my screen? Yeah, I will answer his question like this. His question is, so this is your, and you have connected okay. So this is a very good question, by the way. Everyone, you can see on the screen because his question is good. In an exam setting, you might get confused on this. His question is, what is the difference between these two? This is his question. So this is one chunk, okay? You have connected this chunk with this chunk. Oh, sorry. And here you have this chunk that you have connected with that one. Okay. So in the homework assignment, I have given both these questions. Don't worry. You will solve it, okay? Solve it yourself in the homework assignment. Okay? They are different. So how they are different? In this part, you will consider this whole area, okay? And in this part, you have to consider only this area, because here it is connected by this joint, whereas here it is connected by this joint. Okay, so it will take a little bit of thinking. Homework assignment, I have given these two questions, one on top of each other.
So for shear, this changes the Y bar or A?
It changes the A.
A.
Good question again. 12, 11. Okay, should we cover something new? Any question? I think I have covered everything for today. Okay, let me just, any questions from our online students? Ahsan, Davuka, Davis, Tashin Chan, Aisha? No questions from anyone? Okay, then.
Why we divide by 2?
What?
We dividing small q into the 2.
Oh, really?
Divided by 2, the q.
I haven't thought about it. You are just mentioning, I am looking at it. Yeah, you're right. The forces per unit length on each of these edges. Answer what happened?
You have 2 nails.
I have 2 nails. 2 nails. Yeah, we have two. We have two nails. Okay.
One force on each nail.
Okay, I will not comment on it. I have to read the whole thing and see. Because both the beam and the upper plank are symmetric with respect to the vertical plane of loading, forces are exerted on this. The force per unit length on each of these pins is. There is one on the left and one on the right. So he is right.
So the q will be divided into 2 parts, right?
Yeah, that answer seems reasonable, because it is going like, so we have one on the left and one on the right. But I still suggest that you read it again. That's why I'm not hurrying in my answer. I never read this part, by the way.
And also in this question, delta H is 8.8 libra, right?
80.8. This one?
8.8 libra is the delta H. Right?
Pound is we call this pound, right?
Yeah,
Oh, okay, then that's fine.
So 8.8 pound
Yeah.
is the delta H, right?
That's the delta H.
Delta H.
Correct. You are right. Okay, everyone. What about the other question that I shared with you? Let me share it for our again online students.
But then why isn't there delta X in the equation?
Because the pins are not like this in the longitudinal direction. It's just connected like this.
But it says in the equation, knowing that the spacing between the nails. Is not delta X the spacing between the nails?
Okay, hang on. I have to read.
I mean, not delta X, sorry. Yeah, delta X, sorry.
Where is it?
VQ over I, equation. Isn't there supposed to be delta X as well?
Q is the shear flow for finding the.
No, the equation in general. There has to be a delta X as well, like the spacing between the nails.
Where did they ask? Where did they ask?
Knowing that the spacing between the nails is 1.75 inches.
It's not talking about the spacing between the nails, it's talking about the length of the nails.
No, say spacing between the nails. Is delta X in the equation?
Really?
Tamam işte de tartışıyorsan biraz.
No, Hussein, I answered, Hussein, I saw the 1.75. This one, 1.75 is here.
Oh, he did it later.
Later, he did it
Okay,
later.
okay.
So he used the same formula of delta H, but he
Okay.
used that
Next
later.
one, okay.
Okay. Okay. So let,
Also, if it's supposed to be delta H.
yes, 100%. Okay, let me open the solution. What is the number of problem, please? 6.0. So I think I have covered all the topics for today. We still have 15 minutes. Should I start a new topic? 6.1. Okay, this is for again our online students. Our in-class students are already doing this. Okay, square box beam, the dimensions are given. The question says determine the shearing force in each nail, and then you have to find the maximum shear stress in the beam. So for finding the shear stress in each nail, you know the drill. Highlight the area, find the Q. Q is equal to VQ over I. Use the formula of delta H we talked about, get hold of force, boom. Then for finding the maximum shear stress, you go over this strategy. Maximum shear stress. So where does the maximum shear stress lie? On the neutral axis. My neutral axis is where? On the centroidal line. So yeah, then you find by highlighting this whole chunk, you find the area, you find the Y bar, and boom, you get the answer. Then you find the maximum shear stress. What is the thickness T? The contact. I suppose this is, I don't know, 20. Yeah, I think so. 20. Yeah, 20 by 80 and 20 by 120. This is 20. This is 20. You multiply with the 2. Questions? Huh? In the part B, he is found to rather confusing way. Your question is why did he add 120 into 10 power 3?
From where did he get 2 times 20 times 40 times 20?
No, that's what I am trying to tell you. What he is doing is he is adding the 120 into 10 power minus 6 from the top, right?
Yeah.
So I'm not sure why do we want to make our life difficult. Why don't we find the Q for this section ourselves without even utilizing that one? So how do we find the Q for this one as it is? We will find the area. Oh, then we will have to find the no, not neutral axis, the so I think we should try it. Good remark. So I think what he is doing is he added this 120 into 10 power 3, and then he took this chunk separate. Otherwise, this problem would have become very complicated. No, so he did a 20 multiplied by 40. Say that again. 20 multiplied by 40 multiplied by
Area is 40 times 20.
Multiplied by the 20.
Multiplied by 20 is the centroid distance.
So he is making the Q's separately and then adding them together for his own convenience. Otherwise, if you consider this whole thing, you will have to find the centroid of this chunk, which will be complicated. No.
From the centroid of the part to neutral axis.
No, I will answer. Look, you have to find the maximum shear stress. Where does the maximum shear stress lie? On the neutral axis. Done. Where is your neutral axis? This line. Done. You have to go away from the, so for example, this is the contact. This will be the complete plane of, section of interest. You highlight this one. you have to find the Q. How do you find the Q? You find the area of this chunk. You find the area, then you have to find the centroid of this bizarre shape. And then you have to find the distance from the neutral axis. Oh, come on. If you start finding the centroid of this one in an exam, it will take your time, right? So what this author has done is, he has find the Q of this little chunk. Added. So then he did a 20 by 40 multiplied with the 20 because that is the distance of this section of the neutral axis. Thanks for asking the question. Hafad is your name. Yeah.
What if over here we have symmetrical object? What if we don't have a symmetrical object, then how we are supposed to take the area?
That I can give you in a homework. I don't know, we have to go through some complicated questions. These are for very simple.
Last example we did, okay, the part C was to find the maximum stress, which was at the neutral axis. So over here, are we supposed to take the part
Above or below? Yeah, that's why I also stopped. I have to think about it. When I made that part C, I stopped. Let me repeat your question at least so everyone can think about it, because the whole point of this is that you start thinking. Look, he actually pointed to the same thing that I stopped short of mentioning. When I was going through this problem, I said find the shear stress at A. Where is it? Then find the average shear stress at B. Then I stopped short of saying find the average shear stress at the neutral axis. He has just come up with this question. When you are about to find the maximum average, average shear stress at neutral axis, which will be maximum, would you use the area on the top or on the bottom? Shouldn't it be same? The answer, you try it yourself, double check yourself. Right now I'm not sure, but probably if you do it both ways, shouldn't the answer come out to be same?
technically? Yes.
Right? So give it a shot. Can you take it as a homework assignment? Can we do it right now? 8 minutes. You can try. I think if you take the top section or bottom, the answer should come out to be same. Anyways, something to think about. Then I will post one more homework for you. And that homework has a lot of questions. So the class is pretty much nearing the end. Okay, any more questions for me? Yes.
For this question,
Uh-huh.
in B part,
Huh?
so shear stress in B,
Huh?
we adding the two root terms to in this diagram.
We did not, we did it for our own benefit to find the Q. We said, let's add that Q with the rest of the other Q, because otherwise your problem will become complicated, because you will have to find, you can find the area of this thing, that's fine. But how would you find the Y bar, AY bar? Come on, you have to find the centroid of this bizarre thing, which will be hard for you. Then you have to find the distance from that to the neutral axis. Okay, that will be straightforward, but you don't want to do that.
So the maximum shear stress in the beam exerts on the neutral axis, right?
Maximum shear stress.
Maximum shear stress.
What is the bending stress on the neutral axis? What is the bending stress on the neutral axis?
Zero.
Everyone, Bahadur,
Shear
Hussain.
stress of the topside surface, it will be
On the
zero.
free surface is 0.
Free surface.
Okay, any questions for me? No? We still have 6 minutes. Do you want me to do a quick problem for a new topic or not? Okay. Well, thank you, I suppose. I will post the homework for it right now in 2 hours, 4 hours, and you will have plenty of, when you put the planks like this or that. Huh?
How many questions?
In graded homework, I have to see, I don't remember, but I have made it in such a way that it is interesting for you and it's not too time consuming. Don't worry. Oh, okay, everyone. I wish you a good day. Bye bye. Okay, our online students. Bye bye. Reeves, Tushin Chan, Aisha. Bye bye. Goodbye, Bahadur.